Hey everybody, welcome to this edition of Web3 Builders. Today we have ChainSafe on the Crowdcast, and they're building GOSSAMER, which is the Go implementation of the Polkadot host. So that's a super exciting project, which Amer and Elizabeth are going to tell you all about. But before they get into that, I just wanted to talk a little bit about our grants program and just give you some general information on what we've been funding there. So we skipped the main slide. So the Web3 Foundation Grants Program exists primarily to fund software development related to Polkadot and Substrate, and this is the program that is funding GOSSAMER. And if you look at the graphic to the left there, it gives you a bit of an idea of where kind of the funding has gone since we started the program at the end of 2018. So this graphic's already a bit out of date, but it actually goes up until the end of last year. And so there's been a total of, I think it's now about 250 applications, more than the 200 pictured here. Of those 250, we funded, actually it's now almost 100 different projects. Oops. We're about to do a blog post on our 100th funded project soon, so that's super exciting. And then of those 100 projects, it's now actually that about 50, so just about half have delivered their first milestone. So we're not just funding projects that aren't delivering, people are actually doing work, which is great. And now about 25 of them have actually completed the project, which is awesome. If you look to the right of the page, it gives you an idea of the types of projects we funded. So the majority have been runtime modules. So these are essentially different substrate modules that allow you to kind of build your runtime in a certain way. So this has by far kind of been the most popular type of project we funded. But then when you look at kind of different tooling, wallets, UIs, like different types of what we call ecosystem components, collectively, these are definitely kind of the majority of the projects. So that's exciting. So by looking at this, if you guys are interested in doing a grant project, this gives you a pretty good idea of the types of projects we like to fund. So, and one other thing, actually, we are almost at $5 million in terms of total money deployed, and that's only going to go up. So there is kind of lots of budget for this if you guys are interested. I'd encourage you to apply for a grant. You can go to our website, grants.web3.foundation, to get a better idea of the application process and kind of what you need for that. We have two grants programs. One is the general program, which is our main grants program for funding of up to 100,000, and then our open grants program, which is a fast, kind of transparent program for smaller grants up to 30,000. It's a really exciting one because I think the first application there actually got approved within a day or two. So you often see a very fast turnaround time and approvals there, which is good if you have a smaller grant and want to iterate quickly. If you have an idea of what you want to do but aren't sure it quite fits, I'd encourage you to get in touch. So my email address and Telegram are here, and happy to kind of talk over projects. So without further ado, I'm going to turn it over to Amer and Elizabeth, and they're going to tell us all about GOSSAMER.
All right. I just need to figure out how to share my screen here. Okay. All right, can everyone see that? It looks like we can.
Yep, we can see your slides, and then as soon as you get started, I'll make the slides the focus screen.
Awesome. So yeah, I just wanted to say hi. It's an honor to be here today and talk about GOSSAMER. I've never done anything like this. I don't think Elizabeth has either. It's super cool to be sharing what we've been working on. and really excited to see how this whole interactivity thing works. It looks like you can ask questions and they get upvoted. So we're happy to answer any sort of questions you have throughout this process. But yeah, we can get started. To start off, I'll introduce ourselves. Hang on, let's see if, oh, there we go. My name is Amer, and I'm presenting with Elizabeth. Both of us have been working on GOSSAMER for the better part of a year now, and we've both been at ChainSafe for almost 2 years. And to give some perspective, prior to working at ChainSafe, neither of us had a lot of experience in the blockchain space, which is sort of a testament to ChainSafe's ethos and the blockchain ethos, which is attitude over aptitude. And so I encourage anybody who's looking to get involved with these type of things to just like go for it. But yeah, we're both super excited to be here. And before we get into GOSSAMER, I'll tell you a little bit more about ChainSafe. So what is ChainSafe exactly? First and foremost, we're a community of kind and value-driven people who love each other very much. I find it's very important to actually highlight this fact because, we do work on quite difficult problems. A lot of the times we start projects without even knowing a whole lot about how it is we're going to do what we're going to do. And I think the fact that we actually approach each other in the way that we do and approach problems in the way that we do allows us to solve much bigger problems collectively than we would be able to on our own, and if this fact wasn't true. The other thing is that we love blockchains too. So in summary, we are a Toronto-based, remote-friendly blockchain research and development firm working on building the infrastructure for Web 3.0. An important thing to note is that we are blockchain and technology agnostic. So we're open to working in any ecosystem within the blockchain space as long as the values of that ecosystem align with our own. And you'll see that on the next slide, which highlights some of our projects. We're here talking to you about our work in the Polkadot ecosystem today, which is GOSSAMER. And we'll talk more in detail about what that is. In the Ethereum 2.0 world, we are building an implementation called Lodestar in TypeScript. We have some work in the Cosmos space as well. We worked on Ethermint, and we're actively maintaining that, as well as building an implementation of Filecoin and Rust, which is the network is launching in June or July, which is exciting. And Ethereum Classic, we are maintainers of 2 of the implementations. So yeah, we're very much blockchain agnostic and appreciate the different types of things we learn by working on these different networks. So more about GOSSAMER. So what exactly is it? What it is an implementation of the Polkadot host in GoLang. The Polkadot host was actually formerly known as the Polkadot runtime environment. The naming was recently changed because we found that Polkadot host was a little more descriptive, and the Polkadot runtime environment was a bit hard to understand for some people. But even Polkadot host, I wouldn't blame you if you didn't know what that meant. And essentially what it is a framework for building blockchains. And actually, Polkadot is being built using this framework. And we already have a reference implementation of the Polkadot host, which is Substrate in Rust, being built by Parity. And so you might ask, why also build another implementation in GoLang? And the real reason is, if you're more familiar with Go, then using a Polkadot host implementation in GoLang like GOSSAMER would probably make a lot more sense. And so this project kind of opens up the world of using the Polkadot host to a whole subset, a new subset of developers. And if you do use the Polkadot host, it includes everything you need for a blockchain except for the runtime itself. And so you might be asking, what exactly is the runtime? And in the context of a blockchain, the runtime is the state transition of the blockchain, or in other words, the logic of the blockchain itself. To give you an example, say for the Bitcoin world, The state of Bitcoin at any given time is this set of unspent transaction outputs, which basically describes which addresses have how much Bitcoin. And each block, you get a bunch of transactions which impact the state. So the state transition function is essentially the logic that takes you from one set of unspent transaction outputs to another based on a set of transactions. And so for Bitcoin, obviously, that's very simple. It's just adding and subtracting quantities of Bitcoin from addresses. For something like Ethereum, obviously, it's a lot more complex because you have things like smart contracts. And so with GOSSAMER or any of the implementations of the Polkadot host, if you were to use them, all you'd really have to do is provide that logic and not worry about things like, for example, networking or consensus. And so why would we actually build something like this, you might ask? And so there's two major reasons. And one is creating more secure blockchains, and another is making innovation more accessible. And so let's dive into those two. So the way GOSSAMER helps make more blockchains more secure is basically it allows anyone who's built a substrate-based chain to build another implementation very, very easily. In fact, it's trivial. If you've built a substrate-based chain and you have the actual runtime, which Elizabeth will describe in more detail, but essentially is just a blob of code, you can take that blob of code and just plug it into GOSSAMER, and all of a sudden you have another implementation. And so why is this even important? And so in the context of blockchains, it's important to have multiple implementations to increase the resiliency of the network. The way multiple implementations actually do that is, let's say, for example, you have a bug in one implementation. If that was the only implementation you had, that would risk having the whole network go down. Whereas if you have multiple implementations, you might have a bug in one implementation, but the rest of the network will still carry on. And so it's super important to have multiple implementations to have a more robust network. And so like in the case of Polkadot and GOSSAMER, GOSSAMER will be used once it's complete to build additional node implementations. So right off the bat, Polkadot should have at least an implementation in Go and an implementation in Rust, which is the substrate one. And there's also one being built in C++. The second point or reason why we built GOSSAMER is to make innovation more accessible. And essentially what GOSSAMER and other Polkadot host implementations like it do is that it lowers the barrier to innovation for blockchain development. Right now, to build a blockchain, or up until recently, it's been quite difficult. It's a massive undertaking, and you need, for example, decentralized networking experts. You need, crypto economic experts, consensus experts, and honestly, to do all of that, a lot of times it was hard to get it right. Using something like the Polkadot host or any blockchain development framework, it allows a wider range of developers to actually get involved with blockchain development, and it reduces the amount of effort it requires to actually build a blockchain. So our hope is that once these are out there, people will start using them, and we'll see a lot more innovation within the blockchain space because it's just that much easier to build a blockchain. And so one way to think about it is in the Web 2.0 world, there are web development frameworks like React and Angular that help making web applications a lot easier. And after those types of frameworks came on into the scene, essentially we saw a lot more useful web applications being developed. And we hope to see the same thing with these blockchain development frameworks. A couple of future additions that we've been talking about that should hopefully also make innovation more accessible is a runtime module library in that is compatible with GOSSAMER. So essentially, there's already one in Substrate, but essentially it allows you to not have to build a runtime from scratch, and rather you can plug and play a bunch of modules. And so that makes, not building a blockchain even easier, because not only do you have a framework to build like the core components of the blockchain, but you also have a bunch of modules that you can use to build the actual logic of the blockchain. And then another future addition that we've talked about is building a library to help create parachains. So essentially with GOSSAMER right now, if you were to build it, you would have a sovereign chain. And in order to connect to Polkadot, there needs to be some sort of middleware that allows this blockchain to communicate with Polkadot. And so it would be a lot easier if there was a library to basically do a lot of the heavy lifting there. So now Elizabeth is going to take over. I think, yeah, you're going to share your screen, right? So I'll stop sharing. But essentially, Elizabeth is going to go into more of the technical details about GOSSAMER and all of the components that kind of you get with it.
Sorry, let me just figure out this screen share. Yeah. Can you guys see my screen?
Yep.
Okay, cool. Okay. Yeah, so hey, so I'm Elizabeth. So I've been working at ChainSafe for just over 2 years now, so that is exciting. So I'm just going to go into why we kind of chose Polkadot and GOSSAMER and why we like it. So so this is an overall diagram of Polkadot at a very high level. So the idea is that there's a relay chain and it coordinates the messages between parachains that are all connected to the relay chain. So this provides shared security to all the parachains. So part of the reason why we really liked Polkadot is that normally when you make a blockchain, you're basically stuck making making security from scratch, because you don't need to get validators, you need to get all that stuff. With making a parachain, you can just plug it into the Polkadot relay chain, and you have more security than you would just having a standalone chain. So with Substrate or GOSSAMER or an implementation of the Polkadot host, it makes it really easy to join the network. And also the parachains could be relay chains, so it's sort of recursive in a way, which is really interesting, I think. So that's kind of why we thought it would be very cool to make an implementation. So Polkadot versus the Polkadot host. So the Polkadot host is just a framework for building blockchains. So this provides components that can be used in any sort of blockchain implementation. Sorry. So this is like things like the networking layer, the runtime interpreter, consensus, and a storage tree implementation. So these are sort of things that are in basically every blockchain, but normally you just have to make them from scratch, and that's a lot of work and effort. And like Amer said, you have to basically be like an expert in all of them. So Polkadot is a specific protocol that can be built using the Polkadot host, and any blockchain that's built using the Polkadot host is able to be connected to the Polkadot network. So that's cool. So GOSSAMER. So like I said, it's just an implementation of the Polkadot host in Go. You can use it to create a blockchain that can become a parachain or a standalone chain or anything you want, really. It's just the idea is that with the Polkadot host, you could optionally plug your chain into the Polkadot network. So to implement a blockchain with a Polkadot host, ideally should be really straightforward. So there's a few options. So the first is kind of to just run the node like standalone, like don't make any modifications. This will make kind of like a default chain. So there will be like, you can have transactions. It's like you can have just a normal network with not really any customization. And then this next step would to be customize the runtime. So like Amer said, the runtime is the state transition function. So you could make your runtime be account-based, UTXO-based. You could put like some cryptography, like you could do, you could like snarks in it. You can do like anything, basically. So to implement a chain with a custom runtime, you just have to implement the runtime API. So this is kind of a set of functions that are used to validate transactions and blocks. So you need to implement the API in a language that is compatible or can be compiled to WASM. So this would be like Rust or assembly script. Then you compile it, load it into the Polkadot host, and run it. And ideally, everything should be good. So yeah. And then optionally, if you want to go even further than that, you can rewrite the native language components. So this would be stuff like the networking layer or the consensus layer. If you want to have, if you just want to like customize it to fit your needs, you can. Yeah, the idea is that the like GOSSAMER substrate is modular, and you would be able to easily like rewrite these components, make a new like networking package or consensus package or something like that. So yeah. So yeah, I'm going to talk a little bit about where we are at with GOSSAMER. So yeah, so these are kind of the 6 main components. So the first would be scale encoding. So this is just the custom encoding scheme that's used by Polkadot. So this is finished. The second is the storage tree. So the storage tree is a modified Merkle-Patricia tree, similar to the one in Ethereum. Not exactly the same, but pretty similar. So yeah, this is also complete. The next is the networking layer. So this is done with GoLibP2P, and it is also basically complete. And we're just testing it as well. I'll talk a little bit about the testing after this. And then fourth would be the WASM interpreter. So we used WASMer. So this just basically interprets the WASM bytecode. Fifth is the Bay block production algorithm. This is also complete, and we are testing it. And then last is the Grandpa Finale gadget, which we are to be completed. So, yeah, so right now our focus is mostly on a block production only testnet. So this kind of tests that our networking and block production layers work. Yeah, like with the other components like scale or the tree, it's like easy to make like unit tests to know that it works. But with things like networking and block production, you need to kind of, the only way to test it really is to make an actual network and see like if anything goes wrong. So that's kind of where we're at right now. So yeah, so in the upcoming months, our steps are to finish Grandpa. I'll talk a little bit more about the difference between Babe and Grandpa later. And then stabilize our GOSSAMER testnet, and then eventually full interoperability with Polkadot, and then using GOSSAMER to make a Polkadot node. Yay! So yeah, this is a little bit of the architecture that's inside a node. So yeah, so like I said, there's the networking. So yeah, the networking deals with all interactions with other nodes. So this would be connecting, sending messages, gossiping, that kind of thing, receiving blocks, sending out blocks, that kind of thing. And so this connects into the state. So the state is the state of the current network. So this keeps track of blocks, the current state of the storage tree, the transaction pool, that kind of thing. And then the core is sort of the validation and consensus layers. So yeah, when you get, if you want to update the state, you'd have to kind of put it through the core first. The core would perform all the validations, and then if a block is valid, then you would update the state. And then there's sort of these smaller components like the runtime. The runtime really just is used for block production and validation and stuff like that. And then there's the key store. Yeah, so we actually have a Go implementation of the substrate signature library, Go Snorkel. So yeah, the Rust one is called just Snorkel, I think. So that's kind of cool. And then yeah, just the RPC. So yeah, that's a little bit of inside the node. So yeah, I'm going to go a little into depth about some of the more interesting components. So networking, yeah, like I said, was done with GoLibP2P. So sort of the basic way of how the networking works right now is that two nodes send messages to each other upon connection. And then the message contains information like what network are we on, what the genesis hash is, what our latest hash is. And yeah, so basically nodes use this to match if another node is on their network or not. And then once they have established that they are in fact on the same network, they send block requests, and then to request blocks they don't have, and then the other nodes will send responses if they have those blocks. And that's the basic premise of how syncing works. Yeah, and actually implementing it is interesting, but yeah. Yeah, so then the WASM interpreter. So the Polkadot runtime is, yeah, like I said, in WASM. So kind of the reason why it was chosen to be in WASM as opposed to like a language like Rust or Go is that it's easily, it's runnable in many different scenarios because it's just bytecode. So, like all you need is an interpreter. So you can run it on many different platforms. Additionally, you can store it on chain. So the current runtime is actually stored in the storage tree. So this makes it easy to like update. So you can have, yeah, so like basically updating the runtime would be just a transaction that all the nodes agree on. So this allows for forkless upgrades, which is, I think, really cool. Yeah, so GOSSAMER uses WASMER. So this is so WASMER is originally written in C, and then this is just Go bindings to the interpreter. So yes, this just allows us to import functionality from Go, and then it allows us to call into the WASM runtime. So yeah, WASMER is pretty cool. Yeah, and then block production. So yeah, so like I mentioned earlier, there is Babe for block production and also Grandpa for finality. So kind of the idea with that is these are like two separate functions of consensus. Normally when you think of consensus, they're kind of like smushed together, but it's actually preferred to kind of separate them out into different protocols. But yeah, it makes it more modular. Like if you want to change the block production algorithm, you can do that without having to change the finality or the other way around. So yeah, so Babe is the block production algorithm used by GOSSAMER and substrates. So it's, yeah, it stands for blind assignment for blockchain extension. So what this kind of means is that there is block production divided. So the block production is divided into fixed length epochs, and then each epoch has a certain set of authorities for that epoch, as well as other configuration info. It doesn't change throughout the epoch, and then the epochs divided into fixed length slots. So for each slot, there is there can be between 0 to many authorities that can authorize a block for that slot. Ideally, it's like 1, but in reality, it's like it could be different number. So yeah, so the authorities all use a VRF. So this is a verifiable random function to determine whether they're allowed to produce a block for that slot. So the way the VRF kind of works is it's kind of interesting. So it's a kind you can think of it like a signed hash. So the way it works is that you have your secret key, and then you also have some data that you want to sign, I guess, or it's like input to the VRF, and then this outputs the there's an output created, which is sort of like the hash part. It's like a pseudo random hash, like, and then there's also verification that your signature or your secret key produced that. So it's easily verifiable by other authorities, as well as, yeah, just creates randomness that no one else can create. So I think that's pretty cool. So yeah. And yeah, so yeah, in terms of implementing our testnet, so there are a few stages that can go into this. So the first is literally just running one node, making sure it produces blocks. So yeah, that's done. The next is having one block producer and then many other nodes syncing to that block producer. So yeah, GOSSAMER is also able to do that. And then the last stage is like what you think of when you have a normal testnet, is just many block producers, many nodes syncing to those producers. So yeah, so GOSSAMER is currently in this stage. I'd say it's semi-functional, but it's not perfect. There's definitely a few like kinks to be smoothed out before we actually launch the testnet, but it's getting there. So yeah, that's pretty cool. And then yeah, so a few things that we've learned over the course of implementing GOSSAMER. So yeah, this is the first one is one that I found out rather recently. So yeah, syncing is really hard. There's just like, yeah, distributed systems. There's just so many scenarios, so many things that could happen. Yeah, it's like really makes your brain hurt a little thinking about all the possible scenarios. But yeah, but it's yeah, it's been enjoyable, and I feel like it'll be really satisfying once it actually just works. Yeah, so Next, yeah, targeting moving spec. So Substrate is currently also in development alongside GOSSAMER. So the specification is sort of being written alongside the development. So this makes it, it's just really makes it a bit challenging to keep up. There's definitely been like a few times you have to like rewrite something or like that kind of thing. It's just really cutting edge. So it's hard sometimes, but yeah, it's good. And yeah, the last is just like using new technologies. So stuff like, I remember like a year ago when we started trying to use libp2p, and it's just like not that much documentation. There weren't any projects really using it. It was, there's just like Prism, like, I don't know, like there wasn't that much. And that was just, it was challenging to just get it to work. But yeah, I think now the docs and everything, and there's a lot more, projects using it. So it's definitely improved since then, which is really cool to see. And also GOSSAMER. Around a year ago, we were looking for a WASM interpreter that would work with Go, and like there wasn't really anything at all, to be honest. Like the only ones we could find were like Rust, like C, that kind of thing. So but then eventually GOSSAMER released a Go version of their interpreter. So we were like, wow, this is perfect. So then we tried using it, and there were like a few issues with it, but eventually they just got resolved, and now it works really well. So that's very cool to see. It's really cool to see like this very cutting edge technology getting developed. So that's about it for my presentation. So so feel free to get involved. So on our repo, it's just ChainSafe, github.com/chainsafe.gossamer. There's a lot of issues tagged good first issue that are good for like new contributors. So feel free to look into those issues. There's our Discord, which I believe is in the GitHub README as well. So feel free to message us anytime in the Discord. Like I'm in there, other GOSSAMER devs are in there. So I think that's about it. So thank you guys. Cool. Ooh, wow, recursion.
Wow.
How do I stop sharing my screen? Oh, there we go. Okay.
So it seems like we have a question here.
Okay.
The question is, you've had a lot of experiences working with different ecosystems. Could you talk a bit about your experience working with Polkadot and the teams at Parity and Web3 Foundation? I can take a stab at that. So first of all, it's a massive privilege to be working in all these different ecosystems, and it's really interesting to see how different teams work. And to be honest, like working with Web3 has been an incredible learning experience. I mean, they're really pushing like what's possible in the blockchain space, and I think they do a lot to try and bring people together. So for example, every 3 weeks or so, sometimes every 2 weeks, we have a call with all of the other implementers. And so on this call, Web3, Parity, ourselves, anyone else who's really involved with the building of this ecosystem gets together and chats for 30 minutes to an hour. And so like this allows us to stay in touch with any new developments, to share problems that we're having and work together to solve them. And so that's been super exciting because in some cases maybe you don't have access to the people who are building things similar to yours. And so having that access and having that collaboration is something that I've never really been involved with and has been super fun and exciting. We were all at Web3 Summit last August. And so they got us involved in like doing some presentations and workshops. And so it's been really great to be welcomed into that ecosystem and just working with everyone and being a part of it all, and meeting everyone in person. Everybody's super helpful, and it's just a very collaborative environment. So anything to add to that, Elizabeth?
Like you said most of it. I'd just like to say, we have like a Riot channel where you can talk to the people that are working on Substrate, and as well as the other implementation, Kagome. like anytime. So that's been really helpful for me. Like whenever I get stuck, I can just post in that channel. So yeah, I think that's really cool. Yeah, as well as like Web3 Summit, it was really cool to go there and meet people in real life. So yeah, I've had a really good time. Yeah.
So the next question, what's the best way to mitigate problem with moving specs during development? We had similar problems with Polkadot development, broke API 3 times in a month. That's a hard one. Do you want
to? Yeah, like definitely can relate. I think, yeah, we're still trying to figure this out, but what we've tried to do so far is kind of just versioning. So, like for example, with Substrate, just like picking like a certain commit and being like, okay, like we're gonna develop to this commit and like not update it. Even if the spec, even if we go out of date, it's like, okay, we'll just finish this and then we'll think about moving it to a different commit. Yeah, so it's like, it's hard because you're kind of like always a little bit out of date, but I think versioning for sure is definitely like the only way to kind of deal with that. So yeah.
And one thing to add to that is I think like having an open line of communication, if possible, with the people that are writing the spec is super helpful. And so sometimes, you know, we're aware that they're working on a certain part of the spec. And so if we can wait to work on that part or know that it's going to change, that can affect the way we do development. So I think that really helps. And in our case, it's helpful because we do talk to the team that's working on the spec on a regular basis. I don't know if that's necessarily possible with Polkadot or not, but definitely something that's helped us. Sweet. Next question. Are there any specific needs you have for development help, or are you hiring? Any other details on how developers can get involved outside of checking the GitHub page and Discord or Riot? In terms of specific needs, it's hard to say, but we are always open to contributions on GitHub. And to be honest, a lot of the people that we've hired have come through that sort of path. And so I would really say that's the best way to get involved. For example, like if you take an issue on GitHub, like there's a lot of issues tag good first issue, and you know that's across our projects, not just on GOSSAMER. So really depending on what language you're interested in, what ecosystem you're interested in, there's lots of options. And you know, feel free to pick up an issue, send us a message. All of our teams are very responsive. Like you should get a response like within 24 hours, if not sooner. You know, several people have been hired through that path. And so I would definitely recommend that's the best way to get involved. And yeah, usually it works out pretty well when people do that. Another question, is it possible to build ChainSafe solutions that are already available on other mainnets of other blockchains? I'm not 100% sure what that means, but I think the question is it possible to build implementations for existing blockchains that already have mainnets? And yeah, I would say, yeah, it's totally possible. It hasn't really been something that we've done, although we have worked on implementations that are on mainnets. So for example, with Ethereum Classic, with their Go implementation, we actually implemented several EIPs. So while we didn't build a blockchain implementation from scratch, we actually did work on a live mainnet and worked on an existing implementation. And of course, yeah, if we wanted to build a new implementation, that would be possible. That's just not something that we've done as of yet. Cool. It looks like we don't have any more questions as of now. Don't be shy, though. I mean, if there's any further questions after this, you can reach out on our Discord. So all of our projects have a little space on the Discord, and we're more than happy to engage in discussion there. And obviously on GitHub is also an option. We will be posting the slides after this, so you can look over them, and there's our Discord and GitHub links in there. But we're happy to take more questions now if there are any.
Some links for tools.
So I think that might be it. So I'll get the links and slide link from you, other links that you want to send to give everyone who's joined. But just want to say thanks to you both for coming on and giving the great presentation. It cleared a lot up for me as far as what you guys are working on. So I appreciate the time, and I think everyone really enjoyed it. So thank you.
It seems like we do have one question. Should we take it while
Yeah,
we're
take it.
here? Elizabeth, you want to take this?
Okay, what was your tooling environment for testing multi-node setup? Yeah, so we're still kind of in the process of figuring out what the tooling is. Yeah, like right now it's literally just like basically manually running multiple nodes. But yeah, I think we're working on integrating with Polkadot deployer. So that'll make it easy to deploy multiple nodes at once. Yeah, and then I think we're also working on just like some like network testing and like stress testing kind of thing, and as well as just like integration tests. So yeah, that'll probably just be like using a Docker image, spinning up multiple instances and just like seeing what happens. Yeah, we're still working on this. So definitely, yeah, if you want to keep in touch, just like message in the Discord, and we will answer any questions with regards for that as we keep developing.
Yeah, definitely. Yeah, don't be shy. Reach out. This is something we're actively working on right now. So in the next few weeks, for sure, we will have a much better answer for you.
Yeah.
Cool. Any other questions? All right. I think this time we can call it. Cool. All right, Amer, Elizabeth, thanks a lot for the time. Thanks everybody who joined, and stay safe.
Yeah, thanks everybody. Thanks, Dan.
Yeah, thank you. Yeah, it's great being here.
Yeah, thanks.
Cool.
All right, bye everyone.
Okay, bye guys.